Hey guys, today we are looking at the remainder and factor theorems and using them to solve and divide out some higher order polynomials. So first we need to revisit 4th grade probably, where you did long division. So when you did long division before, if we needed to divide 3,649 divided by 5, well 5 doesn't go into 3. But 5 does go into 36, and it goes in 7 times. So I'll put a 7 there. And then 5 times 7 is 35. So then I'm going to subtract 36 minus 35 is 1. 5 won't go into 1. I'm going to bring down the 4. 5 will go into 14 now. So 5 goes into 14 2 times. So 5 times 2 is 10. I'm going to subtract 14 minus 10 is 4. And then I'll bring down the 9. So then 5 goes into 49 9 times. 5 times 9 is 45. So then 49 minus 45 is 4. And think back. That 4 is our remainder, and so you may have written R4, but what that means is that we have 4/5 left over. Our divisor there, our 5 that we're dividing out, is our denominator, so we have 4 out of 5 left over. This is how it's going to look now, where we're dividing polynomials. So when we divide all of this, what I want you to notice is that we have a placeholder for y to the third. So even though there is no y to the third there, we have a 0 there. We're going to look at just this leading value over here, this y squared. So how many times does y squared go into y to the 4th? Well, we can do y squared times y squared to get to y to the 4th. So y squared would go up here. So y squared times y squared then gives you y to the 4th. And then we're going to do y squared times negative y, or minus y, so we get minus y to the 3rd. And then we have y squared times 1, so we get positive 1y squared. Now we're going to subtract that whole thing. So y to the 4th minus y to the 4th is 0. Make sure you're subtracting everything here. So 0 minus a negative y to the 3rd is a positive y to the 3rd. And then 2y squared minus 1y squared is y squared. So then I'm going to bring down everything. So minus y plus 5. Okay, now we want to look back at that y squared again over here. I want to know how I can put, or what I need to multiply to get from y squared to y to the 3rd. So I need to multiply by y, and a positive y at that. So now I'm going to take that y and multiply it by everything over here. So y times y squared is y to the 3rd. Y times the minus y is minus y squared. Y times 1 is 1y. And I'm going to subtract all of that. So y cubed minus y cubed cancels. Y squared minus a minus y squared is going to be 2y squared. Minus y minus a positive y would be minus 2y. And then I'm going to bring down my plus 5. Okay, so now I need to look, how do I get from y squared to 2y squared? And I would multiply by a positive 2. So 2 times y squared is 2y squared. 2 times the minus y is minus 2y. 2 times 1 is 2. I'm going to subtract here. So 2y squared minus 2y squared cancels. Negative 2y minus a negative 2y, that cancels as well. And then I have 5 minus 2 gives me 3. And remember, that's your remainder. So that goes up here as 3 is our numerator. And then our denominator is y squared minus y plus 1. And that is dividing using long division. So, let's practice another one of these. This time we are using, this time we have x minus 2. So how would I turn x into 3x cubed? Well, I would need to multiply by 3x squared. So I'll put 3x squared up here. So 3x squared times x is 3x to the third. 3x squared times a minus 2 is minus 6x squared. I'm going to subtract this whole thing. So those cancel. Negative 2 minus negative 6 is 4x squared. Then I'm going to bring down plus 2x minus 5. So then how do I turn x into 4x squared? I need to multiply by positive 4x. So 4x times x is 4x squared. 4x times the minus 2 is minus 8x. And I need to subtract this whole thing. So 4x squared minus 4x squared is 0. That cancels. 2x minus a negative 8x is positive 10x minus 5. Okay? Then, how do I turn x into 10x? Well, I would need to multiply by a positive 10. So 10 times x is 10x. 10 times negative 2 is negative 20. I need to subtract this whole thing. So 10x minus 10x cancels. Negative 5 minus a negative 20 is the same as negative 5 plus 20. So we get 15 left over. So that's my numerator up here. Over x minus 2. Now, there's another way we can do this. And we just saw synthetic substitution a few lessons ago. We have synthetic division. And this will only work if we have a linear polynomial that we are dividing by. So in this case, we have x minus 2. So when the degree is 1, we can use this. So when the degree is 1, we have x minus 2 here. We're going to put a positive 2. So you're thinking, what would make x minus 2 0? We're going to put 2 in there. 2 minus 2 would give you 0. What's the 0 there? So 2 goes in the corner, and then we take all of the coefficients. So 3, negative 2, 2, and negative 5. So we're going to do exactly the same problem. We should end up with exactly the same answer, but I think you might like this a little better. So remember that we draw an arrow straight down. So we have 3 out front. 3 times 2 is 6. So negative 2 plus 6 is 4. 4 times 2 is 8. 2 plus 8 is 10. 10 times 2 is 20. 20 and negative 5 gives you 15. Now to write this out, we lower 1 degree from our original. So since we started at x cubed, we now have 3x squared plus 4x plus 10. And then our last piece there is 15 is our remainder over x minus 2. Exactly the same answer, different work. So alternative to long division when you have a linear polynomial would be synthetic division. Right, the remainder theorem tells you if a polynomial is divided by x minus k, then the remainder is f of k. So that's what we just talked about. That remainder was 15 in that past example. Here it says divide x cubed minus 3x squared minus 7x plus 6 by x plus 2. So we have a linear polynomial that we're dividing by, so you can choose to use long division if you want. I'm going to use synthetic division here. So what would make that x plus 2 equal to 0? I'm going to say negative 2. And then I'm going to put all the coefficients in. So I have 1x cubed, I have negative 3x squared, I have negative 7x, and then I have 6. So I'll bring down my 1. Negative 2 times 1 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 5 times negative 2 is positive 10. Negative 7 plus 10 is 3. 3 times negative 2 is negative 6. In this case, my remainder happens to be 0. So bring this down by 1 degree. Since we started at x cubed, we have x squared minus 5x plus 3. No remainder. That's my answer. So when there is no remainder, then the factor theorem tells us that a polynomial has a factor x equals k if and only if f of x equals 0. So do synthetic division. If the last number is 0, then x minus k is a factor. So x plus 2 was a factor in that previous example since we had no remainder. All right, so we have f of x equals 3x to the third plus 13x squared plus 2x minus 8, given that f of negative 4 equals 0. So since we know that negative 4 is a 0, we can go ahead and use our synthetic division. So negative 4 is going in the box because it is a 0. And then we have 3, 13, 2, and negative 8. So we should get 0 at the end. So bring down 3. Negative 4 times 3 is negative 12. I have a 1 here then. 1 times negative 4 is negative 4. Then I get a negative 2. Negative 4 times negative 2 is positive 8. And I get a 0 at the end. So then I know that this is x plus 4, because negative 4 would make that a 0. And then I have 3x squared plus 1x minus 2. So now we can graph this. We have one of our zeros is negative 4. We know that we could factor out 3x squared plus x minus 2. We need something that multiplies to negative 6 and adds to positive 1. So 3x squared multiplies to negative 6 and adds to positive 1. That would be positive 3 and negative 2. So I have 3x, and I have x plus 1, and I have minus 2, and I have x plus 1. So I have 3x minus 2, and I have x plus 1. So then my other zeros would be negative 1 for x plus 1, and then positive 2/3. We also know from our previous lessons that we can figure out in behavior as x goes to infinity. We want to see what f of x will do. And as x goes to negative infinity, we want to see what f of x will do. So, since it is a cubic, we're thinking something like this. So as x goes all the way to the right, f of x is going all the way up. So it's going to positive infinity. As f of x goes, or as x goes all the way to the left, f of x is going all the way down. So negative infinity. So now if I go to graph this, I don't know exactly how high or low it goes on the graph yet. Those are things we'll get to do later on. But I do know where my zeros are. So I have a 0 at -4. I have a 0 at -1. And I have a 0 at positive 2/3. And I know that I am starting below the graph, going up, back down, and back up. So it would look like that. Okay, so to recap, choosing a factor method, common monomials, looking for the greatest common factor, special patterns, grouping when you have an even number of terms, splitting the middle, and now we have added using the factor theorem and synthetic substitution to find some of those factors. All right, guys, if you have questions, feel free to come in and see me. I will see you in class.